here, the memory in PIC18, there are basically three categories of memory. You can call those as a program memory, data memory, and your data square PROM memory. So whenever you are talking it about very first category of memory, PROM of memory, so in that manner, the organization for your PRAM will be like in this structure. So as name itself is telling you, it is PROM there in this particular program memory. By default, very first address, once you provide reset to your microcontroller, this will generate 000H address. So this is nothing but your reset vector address. So you can call this vector address as a reset as an interrupt, highest priority interrupt. Which is initiated and it will generate the address as 000H. So in that manner, it will help you to get the interrupt vector addresses. So all the time, this particular program memory, some reserve portion is there. So after this reserve portion, there is a high priority interrupt vector addresses and low priority interrupt vector addresses. So in order to that, your PIC18 interrupts can be loaded as per the high priority and low priority vector addresses. So these are nothing but a reserve section that is devoted for your interrupts. Clear? After this particular reserve section, and there is a on-chip program memory. Means this particular 64 KB of a single word storage will be there for loading your programs. So even you can say that the rest of the portion of this particular memory will be your user memory space. All the time, whenever you wanted to access any kind of address, you need to have 21-bit pointer must be help you to get in any kind of instruction from this memory location. So for this memory pointer, dedicated pointer is 21-bit program pointer. So if you carefully observe this, this is your pointer, and that this pointer will be helpful to address any of the memory location, even though it is in the interrupt vector table or even of that particular on-chip user programmable area. So all the time, it can be helpful to utilize any general programs, or even in the case of subroutine or interrupt or return from your subroutine, your pointer will help you out in that case. So as per the total size for this memory, you can say that 21-bit is the address for program counter. So it is capable of 2 to the power 21, near around 2 MB of memory space, program memory space is available for user. Okay, so here just quickly revise what we have seen in PROM organization. 21-bit pointer is there. This pointer is dedicated pointer for the PROM of memory. So as per the addressing capability, 2 to the power 21, it will give you nearly 2 MB of program memory space. So this is 2 MB program memory space. Now, whenever you wanted to access these kind of locations, there are some kind of limitations, as there are some kind of boundaries. So these boundaries, even in the case of 2 MB space, all the time, it will, in the case of your subroutine or call instruction or return instruction, in that manner, your pointer will be addressed and returned from it as per the return value. But here one instruction, that is no operation instruction, that is nothing but NOP. So no operation instruction will always will all return as a 0 whenever no operation instruction will be executed. Next, this particular 2 version which is there in front of you, 2520 or and even 4520, each of this having 32 KB of flash memory. So this flash memory you could able to utilize in the way of, let's say, for storing your data or for storing your code. So it can address up to your 16384 single word instruction can be helpful and accessible using the 32 KB of flash memory. Now for PIC18, two important interrupt vectors are there: low priority vector and high priority vector, whose address is 000, and high priority vector whose address is right from 0008 to the 0018. So any one of the address you can write your interrupt service routine. So in order to that, it will again help you to get back to the main program and start the execution in terms of the subroutine if at all it is being called. So this was all about your program memory. Let's move ahead with the data memory. Now, as name itself is telling you that data memory is nothing but this memory is used to store the data. So in order to that, this data memory will be accessible with the 12-bit addresses. So as per the 12-bit, it will allow up to 4096 locations. So 4096 bytes will be there for the data memory. So this particular memory space is divided into banks. Total 16 banks are there, and every bank is 256 bytes. So to access the data memory content, the special function register as well as general purpose register, these two can help you in terms of accessing this data memory. So in order to that, you can say that special function register are used to control the status for any kind of peripheral or special functionality, whereas for the general purpose register, these are capable of loading and storing the data even and from the scratchpad operation, where a user application you will able to take your data. So in short, this whole memory space you can utilize in the way of either directly or indirectly. So your data memory organization is divided into, first point is divided into 16 banks. These banks are accessible with the help of general purpose register as well as special function register. Clear? So in order to that, every bank size is 256 bytes. So here, if at all you are taking bank 0, so it is 256, 256, 256. Likewise, every bank will be consisting of 256 bytes. So to access this memory location, data memory organization, then you need to have access to your general purpose register along with the access for your special function register. Okay. Now, whenever you are saying that I need to have the access for general purpose register as well as for the special function register, how you are going to utilize in which respected bank your data is there. So in order to that, always keep it in mind that all the time bank select register BSR lower 4 bits, and along with that the PIC18 instruction opcode that may be of size 8-bit. So in order to that, combination of that will help you to form the 12-bit address. And now this 12-bit address is nothing but that respected bank address. So likewise, whenever you wanted to access any kind of location, you need to read lower 4 bits of your BSR along with your 8-bit address for the maybe the instruction address. So in that manner, you will able to have the access for that respected bank location as per the size of 12-bit. So in that manner, you will able to have the access. But whenever you are able to access this data memory location, there are 3 ways. So one is using direct, using from your bank select register. So in order to that, for the direct, you will read out 4 bits plus 8 bits from your instruction, and likewise you will able to generate 12 bit for reading out or taking out data from that particular access data register. Or other ways, indirect. Now whenever you are using indirect, is similar kind of indirect addressing mode, where you are indirectly using your file select register that may contain the address of your data register. So in order to that, your microcontroller will able to understand that which respected file select register is there, and that contain the data address of the data register. So this is nothing but indirectly. And the third category to access that data is using general purpose register. Clear? So using this particular general purpose register, you will able to have access for this particular general purpose register using the uh, access bank. So here is one more detailed discussion with that, how that particular data memory will be accessing the banks. Now, as two of the registers are there, GPR and SFR, general purpose register and special function register, all the time your bit set register will hold 4 bit of that respected bank addresses. So this particular bank address register, BSR address, bank select register will hold 4 bit of bank address. Now, as per that 4 bit of bank address, so possible combination will be 16 banks are there. So likewise, you will able to have the 16 bank accessible condition for your BSR. So in that manner, these are the accessing files for your bank. So in order to that, whenever you wanted to access banks, you need to check it out general purpose register as well as special function register. So in that manner, the access register in every region, we are talking about any kind of instruction. Clear? So until and unless instruction won't be there, so along with that, how you're going to only read the data. You need to understand that what could be possibly ways will be there. In that manner, you can able to have the access location for that particular BSR. Clear? So while using this, as far as for the general purpose register, total 0 to 14, I think, yeah, right. 0 to 14 banks are allocated using your general purpose register. Whereas in for the 15th bank, that is allocated for your special function register. Keep this in mind. So all the bank selection using GPR is up to 0 to 14, means total 15 banks will be selected by your GPR and one bank will be selected by your SFR. So in that manner, you can able to have access for that. So if total space is 4 GB, so 4096, so you can have this particular access 4095. So I will write it here. 4095 is the total size. Please bear with my handwriting. And how many possible banks will be there? 16 slots are there. If you calculate this, you will able to figure it out number as 256. Now this 256 is nothing but every bank size. So this is the size and how this particular size is going to get held in the case of the selection of that respected banks. Understood? So at a time, only one register bank will be active. Keep this in mind. So for changing bank register, we need to modify again, of course, the BSR register, lower 4 bit. And upper 4 bit for this particular BSR register is just like unimplemented. So you are not utilizing all those upper 4 bits from your bit bank select register. You are not utilizing it. So as far as the location will be concerned, your data memory can be accessed via directly and indirectly. So direct addressing may be useful or may not be useful for your BSR. But for the indirect addressing, of course, that 12-bit address from your file select register that will be accessing the memory map location for the memory is attached with the program counter. So this is your program counter attached with the 31 level of stack. So this pointer will be accessible for the whole memory space. How much is the memory space? 2 to the power 21. It will nearly give you around 2 MB of program memory space. So this 2 MB of program memory space is divided into three parts. So first part is reset vector. Second part is low and high priority interrupt vector. And third part is on chip programmable area. Clear? So in that manner, you can access this particular memory with three ways. Either you wanted to utilize this will be considered as a interrupt vector table, IVT. So this IVT is nothing but interrupt vector table. So contents of this table is nothing but vector addresses. Likewise, they have categorized it as a low interrupt, priority interrupt and high priority interrupt. So dedicated address is given. What is that dedicated address? 0008 0010. So these are the low and high priority vector addresses. Now, in that manner, all the time in the way of subroutine or main program execution or any kind of interrupt execution, all the time it must have return value. So that even though your program will enter into the interrupt, after the completion of that interrupt execution, it has to go back to the main memory. Always keep this in mind. Clear? Now, this particular data memory, for this memory, 21 bit pointer is there, and due to which the size becomes 2 MB. But whereas in for this particular data memory, the pointer is 12 bit, which will allow up to let's say 4096 bytes of data memory. And along with this 4096 bytes, this 4096 bytes of data memory space is divided into banks. Clear? So in that manner, you can see that these are nothing but banks. How many total banks are there? In 8051, 4 banks were there. So just like that same concept here, this particular data memory organization allows you up to 16 banks. So these are your 16 banks. So 0 bank to 14th number bank is accessible via general purpose register. Whereas in for the 16th bank, that will be accessible via special function register. So in order to that, every bank size is 256. So total data memory space address up to 4 KB. And for the data register map with the 12-bit register, so it will allow the addressing from 0000 to FFFF. So these are the data registers map. So here are dedicated data register map. So along with that, you can able to access the particular bank with the location for that respected address. So this was all about your data memory organization. Now, whenever you wanted to access this memory organization, again, data memory can be accessed via three ways. One is direct way, one is indirect way, and one is through general purpose register access. So direct way will simply allows you to access data memory with 8-bit of address, instruction address, along with the lower 4-bit of bank select register, lower 4-bit. So combination of these two, 8 plus 4, 12. So this 12 will help you out to access that data memory location anywhere in that data memory. Why? Because you are directly specifying here. what is the exact bank location address and what could be the possible opcode for that respected address. So these two will get added, and so that you will able to address out one certain location out of that 15 banks, sorry 16 banks. Okay, so another way, either you can take a help of your file select register. So in that manner, you can utilize that particular file select register. Using that, you can say that this is indirect address for that memory location and take out data. That's why it is referred it as a indirect, because here address is being routed through your file select register. And third case is for your general purpose accessing of that bank. So in that manner of general purpose accessing bank, so this specific address will be given with respect to the bank and general purpose register, through which you will able to address location from your memory locations in the data memory.